All right, today we are starting section 4.6. It will be our last new section this week. We will probably spend the last 2 days of the week reviewing it and take a quiz early next week, just so you know what's coming. And then next week we'll probably also have our chapter test over chapter 4. Big stuff coming up. So today for 4.6 we are going to multiply binomials and polynomials. So yesterday it was with monomials. Today is binomials. Who can remind me what a binomial is? Keon? Not necessarily two variables. It could be. Houston? Two terms. Good. A binomial has two terms. All right, our warm-ups are similar to that worksheet that we just did. We are going to be distributing the term out in front of the parentheses into the parentheses. If I take 3x times x squared, Ryan, what do I get? 3x cubed, good. Next I've got to take 3x times negative 2x. Lexi, what do I get? Negative 6x to what power? Second, good. Sorry, I just didn't hear you. All right, and finally we're taking 3x times 4. Logan, what does that give us? 3x times 4. What do we get? You don't know 3x times 4? No. Sure you do. What's 3 times 4?
I don't know. 12x.
Okay, 12x.
Yes, 12x. Thank you, team. Are we ready for number 2? We're ready? Some of us are? Someone keeps saying no. I don't know who's not ready for this. All right. We've got to distribute into the front parentheses, and a little different from yesterday, we're going to have to distribute into the back parentheses. And then in the middle, what are we doing? Adding. So I'm just going to drop that addition sign for now. Kelby, in the front, when I take 2x times x, what do I get? Beautiful. 2x to the second power. Deshaun, what do I get when I take 2x times negative 3? Beautiful. Then we move to the back. Houston, when I take x times 5, what do I get? We get a 5x. And then we take x times negative x. Jamal Dixon, what is that? Negative x to what power? Squared. Beautiful. What can we do now? Combine like terms. Add or subtract, whatever the operation may be. What can I combine with this 2x squared in front? Keon? The negative 1x squared from the back. So I can take 2x squared minus x squared. What does that give me? 1x squared. 2 minus 1 gives me 1x squared. If you would like to write the 1, that's fine. All right, then in the middle, we have a negative 6x plus 5x. What will that give me? A negative x. Negative 1x. Again, if you want to write the 1, that's fine. You do not have to. Why can I not combine these two that are left? Good. They've got different exponents, so they cannot be combined. All right, our notes for today are pretty short. It says you can still use the distributive property to multiply two polynomials together. It is useful to rearrange the terms of a polynomial so the degrees of the variable are in increasing or decreasing order. For example, down at the bottom there, they show a polynomial where we have which exponent first? 3, and then 2, then 1, and then 0 or none. Okay, so they have the exponents in decreasing order. Usually you'll see them in decreasing order. Sometimes maybe it'll be increasing. All right, the note said that we could still use the distributive property. But when we have a binomial, meaning 2 terms, we are going to have to distribute 2 times. Okay, so if there's a binomial in the front that we're multiplying, we distribute twice, double distribute. What that means is I am first going to distribute the x into the second set of parentheses. After I'm done distributing the x, what do you think I would have to do after that? Distribute the 4. So I'm going to distribute both the x and the 4 to the second set of parentheses. So let's write out what that would be. So first I would take x times x. Then I'm going to take x times a negative 1. So how you do your signs is kind of up to you, but a positive times a negative means it's going to be a negative. So if you want to put the negative 1 first and then the x, you can. Then we're going to take 4 times x. A positive times a positive means my sign will stay positive. 4 times x. And then in the back we've got 4 times negative 1. Positive times a negative would come out to be a negative. Okay. So kind of how you write this step out, honestly, you probably won't write this step out very often, but this is just showing you what we're doing. All the things we're multiplying together. So I put whatever sign I'm going to want in the end. So I put a plus on the 4 times x because they're both positive. I put a minus on the 1 times x and on the 1 times 4 because those will end up negative. As we were going through this, some of you are already telling me what these things would equal. If I take x times x, that gave me what? X squared. This would just become minus x. A negative 1 times x is just minus x. Here it's already kind of written for us. That would be a positive 4x. And then on the end, what would I have? Minus 4. What can happen now? Combine like terms. Which terms are alike? The negative x and the positive 4x. So the x squared is not changing. Negative 1 plus 4 gives me a positive 3x. And the minus 4 on the end is not changing. Can anything else be combined? No. So that is our answer. Notice that it is in decreasing exponent order. 2, 1, 0. This first line that I wrote here, I do not necessarily expect to see that. I was just showing you what we're multiplying together. So if you did not show that first line, that's fine. I do want to see the second line. I want to see that and then also your answer. That is my expectation. Are we ready for the next one? Okay. Remember to be careful about your signs when you're doing this. So first we distribute a y. Deja, what is y times y? Good. Y to the second power, or y squared. We've got y times a positive 2. That's going to give me a positive 2y. Next, what do we need to distribute? A negative 6. Good. We need to treat that 6 like it's a negative. Negative 6 times y. is negative 6y. What about negative 6 times 2? Negative 12. Questions about the double distribute step? Okay. Then we still need to we distributed. After that, we combine like terms. Again, our like terms are in the middle for us. So the y squared stays the same. 2 minus 6. So it's a negative 4y in the middle. The minus 12 isn't changing, so it stays on the end. Nothing else can be combined. We've got it in decreasing order of exponents, so we are done with number 2. All right, when we double distribute, we should show 2 lines of work. One being our initial double distribute, and then after we combine like terms. 5y times 2y. Who can tell me what it is? 10y squared. Good, there's a team effort. Don't forget the squared, otherwise it'll mess you up when you combine like terms. 5y times negative 3. Good, a couple of people know it. Negative 15y. 4 times 2y. Positive or negative? Positive, so make sure you write that plus sign. And then 4 times negative 3. Negative 12, good. We combine like terms. So once again, it worked out for us that the terms we're combining are in the middle. Negative 15y plus 8y. Negative 7.
It's positive on our page. It's plus 3.
Well, all right, we'll change this problem to match your paper. So if I change this to a plus 3, then what else has to change back to a plus? The 15 and the 12. Okay. All right, so now this will match your paper. Are we okay now? Okay, so now when we combine, we've got positive 15 plus 8. 23. Should it be y or y squared?
Just y.
Why is it just a y?
Wait.
When we combine like terms, we leave the exponents alone. Okay? Combine like terms, you leave the exponents alone, so it's just a y. And then what's going to be on the end?
Plus 12.
Plus 12. All right, 6t times 3t. 18t squared. 6t times negative 5. Negative 30t. Negative 1 times 3t. Negative 3t. Negative 1 times negative 5. Plus 5. Good. We combine our like terms. What are our like terms? Negative 30t and a negative 3t would combine to give us negative 33t. Is anything else changing? No, so it just comes down as part of our answer. We can't leave it off. We just put it back in their spots. Make sure if you have a problem that has a t as a variable that you put a little tail on your t's. I don't want your t's looking like plus signs. Or if you want to write a cursive lowercase t, that would also be okay. Are we ready to move on? Has anybody else already tried to move on their own? A few people. Good. All right. On example 5, what's the first thing I'm going to distribute? 3b to 2b and 3b to negative 3. What's the next thing I would distribute? The 9 to the 2b and the 9 to the negative 3. If you want to think about it one step at a time, that's fine. I like to write my little arrow arc marks at the very beginning and then just follow them one at a time. Danielle, what's 3b times 2b? 6b squared. Natalie, what's 3b times negative 3? Negative 9b, good. Next up, we've got 9 times 2b, Keon. Nine times 2b. 18b, positive 18b. And last, we've got 9 times negative 3, Kion. Good, negative 27. All right, when we combine like terms, Jakeem, what do we get in the middle? Positive or negative? Positive 9b. When we combine our like terms in the middle, the 6b squared and the negative 27 stay the same. Questions before we do the next one? All right. Next one, what's the first thing I distribute? All right, we've got different variables. So the first thing we distribute is the 9d to y and to the 7. Then we would distribute what? The negative 4 to y and 7. Okay, if we take 9d times y, what does that give us? 9dy. Okay, those are not the same variable, so that they cannot be combined into one. Their exponents don't change. They're just all smushed together. What about 9d times 7? 63d. Now we're on to that negative 4. Negative 4 times y is negative 4y. Negative 4 times 7 is negative 28. Can we combine anything? No. None of them have variables that match completely. Okay, so we've got a dy, but this one only has a d, that one only has a y. So nothing combines, we leave it alone. All right, let's move on to number 7. What's different about 7? Three terms in the back. Good. Our process doesn't change. We're going to take the s from the front and distribute it to everything in the back set of parentheses. Then after that, we're going to take the negative 2 and distribute it into everything in the back parentheses. Same process, just more stuff. Okay, so let's start off with distributing the s. If I distribute s to 4s squared, Delaney, what do I get? Good, 4s cubed. Then I've got s times 5s, Connie. So s times 5s, that's where we're at. So what power? We got 2 of them multiplied together. Second power, good. So positive 5s squared. Then we distribute the s to the negative 3. Jeriel, what does that give us? S times negative 3. Negative 3s. Wonderful. All right, next thing we got to do is distribute that negative 2. Negative 2 times 4s squared. Anybody? Negative 8s squared. When I write out my work for these, if I've got 3 of them in the back, I like to line them up. So once I distributed the first time, when I go back through and distribute the second time, where do you think I want to write that negative 8s squared? What should I put it under? Natalie? The 5s squared. So I like to go ahead and line up my like terms as I go. You do not have to do that. If you want to keep writing it out to the side, that's fine. But I like to line up like terms so that it makes it easier for me to combine them. Keon? Okay. We shouldn't have had to double distribute on the homework last night. But I'll take a look. All right, then we take negative 2 times 5s. Negative 2 times 5s gives me negative 10s. Where do you think I want to write that? Under negative 3s. And then negative 2 times negative 3 would give me a positive 6. Where do you think I want to write that? At the end. I like that idea. There are no other constants up there, so I'll make it its own column. Now when we go to combine like terms, it's really easy because I lined up my like terms already. There's nothing else like 4s cubed, so it just comes down. If I take negative 5s squared, combine it with a positive 5s squared, combined with a negative 8s squared, what do I get? Negative 3s squared. Next, I combine a negative 3s with a negative 10s. Negative 13s. Nothing to combine with that plus 6, so it just comes down. And there's our answer. Okay, again, if you don't want to line up your like terms, you don't have to. You can keep writing it all out horizontally. Just helps me to line them up to combine like terms. Once again, we are double distributing. The first thing to get distributed is the 2y. Ooh, not far enough. There we go. The other thing to get distributed is that positive 1. Do I have any volunteers to tell me the whole thing I get when I distribute 2y? So all three terms. Jay Sean?
2y cubed plus 2y, no, minus 2y squared
Good.
plus 6y.
Beautiful. Okay, so we distributed the 2y the whole way through. When I distribute a positive 1 through the second set of parentheses, does multiplying by 1 change anything? No. So I'm going to get exactly that same polynomial when I distribute a positive 1 to it. So that gives me y squared minus y plus 3. Are we all okay with that? Distributing a positive 1 makes all those terms stay the same. Then we have to combine like terms. Nothing to combine with the 2y cubed. Is this y squared down here positive or negative? This one's positive. We could put a 1 in front of it if it makes it easier to see what to do. Negative 2 plus 1 is negative 1, so I would have minus 1y squared. If you don't want to put the 1, you don't have to. We can go either way on that. Positive 6y minus y. Again, if it helps to put the 1 there, you can. Positive 5y. And then we've got a plus 3. That one's not changing. Questions, concerns about number 8? Nothing? Okay. What's different about number 9? We've got 2 different variables to work with, but that's fine. We're going to treat it the same way. We just might have to put a little more thought into our answers. We distribute 2x times 3x squared. What do we get? Good. 6x cubed. We take 2x times negative 2xy. 2 times negative 2 would be
4x squared y.
negative 4x squared y. Good. X times x is x squared. There was nothing that changed that y, so it just came down, multiplied to it. Then we've got 2x times y squared. Jay Sean?
2x y squared.
Good. Again, it's all getting multiplied together, but there's nothing that's really changing the 2x or the y squared. Then we distribute through a y. We have y times 3x squared. Ryan?
3x squared y.
Good. So we've got 3x squared y. I'm putting it underneath the negative 4x squared y. So their variables and exponents match. We've got y times negative 2xy. Good. Negative 2xy squared. The y times y gives us the y squared on the end. Again, I lined it up underneath the other one that had xy squared on it. And finally, we take y times y squared. Y to the third power, y cubed. Finally, we need to combine like terms. Nothing to combine with the 6x cubed. Negative 4x squared y plus 3x squared y. Negative 1x squared y. What happens to the 2xy squared and negative 2xy squared? Good. They are exactly the same with opposite signs, so they cancel out. Finally, on the end, I would have plus y cubed. All right. I know we've still got a couple more examples. We will save those for tomorrow. But we do have
Homework.
homework.
I love homework.
I know you do. All right. I will leave off number 40. I'll take that away. So we are just doing 162, 14 through 32 evens. Make sure you're showing multiple steps because most of these require multiple steps. Maybe not all of them, but most of them.
You said 4 through 32?
14 through 32 evens.